So I'm going to give you a problem. We're going to factor it, and then you're going to scratch out the problem on your sheet. Ready? Okay, so the way that you get credit for participating today is you're going to write number 1 on your sheet. Alex, if I could beat you over the head with a chair, I would not do it because I like my job. Okay, number 1. The problem is v squared minus 36. V squared minus 36. So you are going to factor this on your paper. Everyone's going to factor it on their paper because I'm not collecting your bingo cards, I'm collecting your papers. So factor it on your paper, that's the important part because that's what you're going to turn in. And then you can scratch them out on your bingo sheets. Anybody get a bingo yet? Just kidding. Just kidding. Not yet. Everybody only has 2 squares filled in, the free space and then this answer. Every single answer, it will always be on your bingo sheet. I'm telling you. What type of factoring is it? Anybody? Yes. Perfect square. So I'll give you a clue. It should be 2 sets of parentheses, 1 with a plus, 1 with a minus. Does that help? Yes, yes. Okay, are we ready for the next problem? Okay, number 2. Okay, here's the next one. Number 2 is going to be 3r squared plus 4r. 3r squared plus 4r. What type of factoring is this? Is it a slide divide? Is it a trinomial? Wait, is it a trinomial? It only has 2 terms. It's the greatest common factor. Ooh. Greatest common factor. Yes, GCF. It's the nice one, it's the simple one. So how many sets of parentheses should you have? Just 1. 1 set of parentheses, not 2, just 1. Like this. Okay. All right, number 3. We're going to use our brains a little bit more on this one. Are you ready to use your brain a smidge more? It wasn't a test, it was a quiz, so we can. All right, a squared plus 18a plus 80. A squared plus 18a plus 80. What kind of problem is this? A trinomial. Is it one of the ones that's like easier or one of the ones that's a little bit more difficult? Is one of the easy ones. Okay. So how many sets of parentheses? You know what, Alex? Okay, let's not be sassy about this. Let's not be sassy. Yeah, that is always the question. Well, let me tell you guys. I one time at one moment in my teaching career, I had a kid standing in my face screaming curse words. And I just had to say, I like my job, I like my job, I like my job. I will not be fired today. I will not be fired today. I will be appropriate. I am an adult. Nope. 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 There are things I could have said, but those are not the things I would have said. All right, number 4. Alrighty. This one we're going to use our brains a little bit more. Are you ready? 3x squared minus 17x minus 6. 3x squared minus 17x minus 6. If we need to do this one together, we can, so give it a shot. What type of problem is this one? Slide divide. Now, some of my students who were in Math 2 last semester, they called it a slip and slide, and I was like, no, we are in high school. Slide divide. Pete, we are on to slide divide, not slip and slide. We call it slide divide. We are in high school. We are not in Miss Chun's class anymore. We are mature. We slide divide. We do not slip and slide. We slide divide. Okay, see if your notes will help you. See if your notes will help you on this one. Okay, what are you trying? You're trying to see what multiplies to what number? I don't think that's what you're trying to find. Negative 18, there we go. So you're going to hit the y equals button, and you're going to say negative 18 divided by x. And then once you typed that, you're going to hit second graph. And then when you look at the table, you're going to be like, these top ones up here, these add up to positive numbers, so I don't think I'm going to look at these. I think I'm going to look at these because these are adding up to negatives. Does anyone need me to show steps? Yes? Okay. So what is the first step of this problem? Slide. Okay, so we're going to take the 3. We're going to slide it over to the negative 6. What is 3 times negative 6? Negative 18. So we are looking for 2 numbers that multiply to negative 18 that add to negative 17. 1 and negative 18. Because that's not the final answer. We still have 2 more steps. So we write this in parentheses. We write x plus 1, x minus 18. But we still have 2 more words. We've only done slide. What are the other 2 words? Divide. Okay, what number are we dividing? The 3. So we're going to do divide by 3. Divide by 3. Now we have to look and see if these fractions actually divide. So 1/3, can that be simplified? No. 18 thirds. Yes, what is that? 6. Okay, so I'm going to keep the x plus 1/3 because that could not be simplified. 18 thirds, you said yes, it simplifies, it becomes 6. Okay, and then what is the last word? Bottoms up. 3 in the front. Okay, so 3x plus 1, x minus 6. Now, can you find that? There's not a typo.
On the bigger cards, it's v minus 6.
Well, then how do you know it's not a different problem?
Because there's nothing else where that's near the answer.
Only one of mine says v. One of mine says x, one of mine says v.
Yeah, same.
Oh, that is a typo. You guys will live, it's fine. Okay, so
if you don't have v, you shouldn't write it.
I think we're all fine.
Yeah. One of these days we should play 3-dimensional bingo.
Is that where I high five with the chair? No. Okay, we're gonna move on. Okay, next problem, number 5. All right. All right. Okay. Are we ready for another one like that? Yes, Miss Rice. Okay, this one is 5x squared minus 17x because the 17 was so fun last time. Minus 12. It's very similar to the last one. I'm just giving you a chance to do it on your own this time. Or, you know, we can do it together if we need to. Miss Rice, I just love factoring. I know, me too. It's fun. It's so fun. What part is the frown?
I got different numbers.
What numbers did you get? But you would have two negatives, which would multiply to a positive. Yeah. It's an easy mistake to make. Miss Rice, this is so wonderful. I feel so relaxed. Can we just do bingo every day? Uh-huh. I'm a big fan of math where you get to check yourself.
A completely rigged game.
How is it rigged?
I have 3 cards.
But everybody has more than one card.
Wait, who complains about something being rigged when it's rigged? Yeah, like one
I know, yeah. Why are you mad that it's rigged in your favor? I'm selecting the problems so that you guys don't have a bunch of hard ones in a row. Like, this is what I'm looking at. I'm looking at all the problems, and I'm just like...
Oh, so you actually don't have a card?
No, I have a card, but...
No, I mean, like, you don't have a card that's going to win 100%.
I mean, I could win if I wanted to, but I'm not... I'm not, like, looking at the answers making myself when I'm looking at the problems so you guys don't have, like...
Oh, I thought it was, like, a list of problems and one card and all the others.
No. I picked problems so that we would do a random assortment.
Can you give us that b squared plus b question?
No, I'm gonna avoid that one. Sorry. Okay. All right. Are we ready for the next one? Yes. Okay. So this one we're gonna do 12p squared plus 6p. 12p squared plus 6p. I basically can't let myself win because everybody would think that I cheated. They'd be like, "Oh no!" I have to lose. But also, like, how do you have your own bingo card, have all the problems, and still not win? It's like you're really bad at bingo.
So, yeah, there's only one p on the answer sheet. So.
Yeah, but if you do it by just looking at the answer sheet, then you're kind of just cheating yourself. You can use it as a confirmation.
Yeah, you can use it as confirmation. What type of factoring is this one? Yeah, GCF. Wireless. Okay, this next one is going to be definitely a calculator problem. It's going to look worse than it is. Okay? Okay, can we agree to not be intimidated? Okay, here we go. 25 n squared minus 195 n plus 140. Whew. Them are big numbers. Yes. Okay, so let's take out the GCF first, and then we'll walk through it. Okay, so what's the GCF? 5. Okay, so we take the 5 out, and then what do we have left over? Wait, n squared? 5n squared, okay, minus, okay, plus 28, okay? And what type of problem is this? Slide divide. Okay, so now what are we going to do? Okay, 5 times 28 is 140? Okay. All right, so 140 is the number we're putting in the table. Okay, so we're going to hit the y equals button, y equals, and we're going to do 140 divided by x. And then we're going to hit second graph. And we're looking for the ones that add up to negative 39. So when we look at our table, we don't want to go down because these are the ones that add up to positive. So we want to go up. Negative 141, negative 72. So if we go up, we're going in the right direction. Second graph. Yeah. And I can see it on the screen right now. Anyone see it? Uh-huh. So negative 4, negative 35. Okay. So GCF of 5. N minus 4. N minus 35. And done. No. Okay, then what do we do? Divide the 5. So the number we slid, we divide by. Okay. And then we go straight to bottoms up. We don't do anything else. We just go straight to bottoms up. Okay, so this is divisible by 5. Okay, so what do we say here? Okay. So this is n minus 7. Is this, can we reduce this? No? Okay, so 5n minus 4. 5. Okay.
I got bingo.
Alex got a bingo.
I win.
You win?
Yes, I win.
Okay, Alex, tell me what your spots were. Read them slowly.
5 times 5n minus 4 times n minus 7.
Okay.
3x plus 1 times b minus 6.
Nice. Got it. I got you. Okay.
Free space.
Okay.
R times 3r plus 4.
Okay.
B plus 6 times b minus 6.
Marvelous.
What do we got?
What? Okay, you got the first bingo. Anybody else have a bingo? Should we play to the second bingo? Would you like? Okay. All right. We comfortable with that problem? Okay. Is there a specific type of problem we feel like we need practice on? Slide divide? All right. Here's another slide divide one. Number 8. Mm-hmm. 15k squared plus 155k plus 350. No surprise, these numbers are so big. Yep. Yepers. Not a 15. Just a 5. Anyone come up with the two numbers? What are they? I have 2 almost bingos.
I have like 7 of them.
Another almost bingo. Should be winning. You feel better about slide divide? Yes. More slide divide? Are they our new favorite?
This is what I just needed.
Yeah. There's something kind of nice about them.
I do like slide divide, but this is just what I need.
Yeah. Some people like to do these types of problems by guess and check, and I'm like, why? If slide divide works and you don't have to guess?
Because it's unintuitive. Problem is, there's no way for me to make it equal to what, like I like to be able to have it equal the same thing throughout the whole problem. When you do slide divide, that's not always true.
What?
Like I don't like to have to remember that there's a 3 I gotta put in later. I prefer if I can, that's the whole problem.
I just don't like doing anything that makes me want to punch myself in the face,
Like,
which guess and check does.
like when you multiply by the 3, it seems like you should put a divide by 3 underneath the rest of the equation after that.
Well, you multiply by 3, so later you have to divide by it. That's intuitive.
Right, but you should write that in if you have to divide by 3 there. You have to remember it.
Slide divide?
Like,
do you want to call it multiply divide? Would that make you feel better?
No, I'm just saying write in a divisor bar underneath things in parentheses and put 3 there so that you remember that you got to divide by 3.
So we're going to call it
It looks like a kind of concordant smiley face in a way.
No,
it looks like a brain.
Yeah.
Like the little
Yeah.
circles. Looks like a what?
that looks like a table flip
little
emoji.
arrows.
Oh,
yeah. That's what it reminds me of.
That looks like a table flip emoji.
all right, let's do this one real quick and then we'll go back to slide divide. X squared plus 2x minus 35. X squared plus 2x minus 35. How do we know it's not a slide divide? Yeah, the x squared is all by itself. No number with the x squared. That one did not help me at all.
Literally surrounding a number.
Did nothing. It did nothing. Oh. He said, oh, okay. I win next. Okay. Let's go ahead and pause right there. Remind me, let's do a slide divide or 2 tomorrow at the beginning of class so that we can kind of spread it out some days. Okay, I do have some more on here. Okay. So at the top of the page, write factoring bingo. And make sure you put your name on this and keep it safe and ready to turn in for tomorrow. So factoring bingo, keep it safe, keep it ready to turn in tomorrow. And then get your notes out from last night. We are going to add to them because we have a 5th type of factoring. Okay, so here's my notes from last night. We're going to add to them. You're going to save them and put them on the refrigerator when you get home. Say, Ma, look what I did today. Yeah, or you can recycle them. Either is fine. Okay, for the next part of the notes, you're going to need two colors. Two colors. They could be marker, they could be colored pencil, but you're going to need two colors. You could do highlighter. I would not do yellow. You could do black and pencil. Yeah. So two colors. Pencil counts as a color. Pete got a bingo. Okay. So we have our factoring notes. We are going to take our factoring notes and add number 5. Number 5 to our factoring notes. From the video last night. What? I literally wrote it on your little clipboard. Factoring notes. Yep. All right. Number 5 is sum or difference of cubes. Sum or difference of cubes. Oh, you're not exempt from this. You still have to take these notes. So you got a paper out? Nope, new sheet of paper. Notes. Sum or difference of cubes. Okay, so the first thing we're going to do is write the formula down, and it's going to look scary, but it's not scary, okay? Because there's kind of like a rhythm to it, if that makes sense. It doesn't make sense yet, but it will. So a cubed plus b cubed, this is the sum. We're going to write the sum formula first, then the difference formula. So the sum formula goes a plus b, that's the first parenthesis. And then the second parenthesis is a squared minus ab plus b squared. And I know it looks complicated, but bear with me, okay? That is the first formula. The second formula is for the difference. A cubed minus b cubed equals a minus b, and then it is a squared plus ab plus b squared. So the formulas are very similar, but slightly different. It's the signs that are different. So here's how we remember the signs. It is the acronym SOAP. SOAP, okay? In the parentheses, the first sign is the same as the problem. So if you have the sum of cubes, then the first sign is the sum. If you have the difference of cubes, then the first sign is the difference, okay? Same sign. The second sign is the opposite. So the first sign is the same, second sign is the opposite, okay? The third sign is always positive. So your acronym is SOAP. S-O-A-P, SOAP. Okay, now get your colors out. This is the other part of how we memorize it. So the first part we memorize is how the signs work. We memorize that with SOAP. Same sign, opposite sign, always positive. So that's easy, okay? Now the other part, students are like, how in the world am I going to remember all the A's and B's? This is the part students are confused about. Well, here's what I noticed when I started color coordinating this when I taught it to students. If we take this a cubed plus b cubed, and don't write it yet, just watch for a second, a cubed plus b cubed, and we start doing the colors, we have A plus B. So you can see my first parenthesis, I just split in half with the colors. Everyone see that? First color, second color. Okay? Then I have A squared minus A times B. And then I have this B plus B squared. Do you see how I split it in half again? So it's like half the colors, half the colors. So there is kind of a rhythm to it. So when I do this, I don't memorize the formula. I memorize the rhythm. I memorize soap. And then I just think half, half. So there's two things multiplied here. It's A times A, and then it's A times B, and then it's B times B. So two things, two things, two things. And then the colors are half each time. Does that kind of make sense? So if you memorize the rhythm of how this works, it's a little bit easier than just straight up memorizing the formula, which feels kind of complicated, okay? All right, so let's go ahead and write down a problem. So here's our example. So we have 8x to the third minus 27. Did not need a parenthesis there. Okay, so what I'm going to do first is I'm going to rewrite this. So we have a couple perfect cubes we're just going to write off to the side. 1 to the third is 1. 2 to the third is 8. 3 to the third is 27. 4 to the third is 64. 5 to the third is 125. 6 to the third is 216. 7 to the third is 343, I believe. Don't quote me on that. Hold on. 7 to the third. Yeah. That's about as high as we're going to go.
I think the answer is 512.
512 for what?
82.
Hold on. Yeah, it is. Okay.
I know my five.
So we're going to take this, and what we're going to do first is we are going to rewrite it as something to the third minus something to the third. Okay? So first I've got 8x to the third is actually 2x to the third, and 27 is actually 3 to the third. Okay? So 8x to the third is actually 2x to the third. 27 is actually 3 to the third. Okay? Now, what I'm going to do to factor this is I'm going to start with a little parenthesis, and then I'm going to have a big parenthesis, and I'm going to make it extra big because I'm about to use marker, and I'm going to kind of expand it out. Okay? Now, I'm going to have same sign, opposite sign, always positive. Okay? Same sign, opposite sign, always positive. And now I'm going to use my colors. Okay? Are you guys ready? Okay. So 2x is the first one. So I have 2x times 2x, and 2x. See how I did half? Okay. Now I'm going to switch colors. My second color is the 3. 3 times 3. 1. And then this is 2, 2, 2. We see how it works? Okay, so now I'm just going to take my pencil again. I'm going to clean everything up. 2x minus 3, 4x squared, because I have 2x times 2x, 2x times 3 is 6x, and 3 times 3 is 9. Okay. How are your brains? Wrinkled?
Right.
So 8 is 2.
Oh, okay.
So 2 to the third, and then the x would be 2x to the third. So 2x times 2x times 2x is where they got 8x to the third from. Yeah. Okay, brains are okay?
Right. But it was the